Some of the differentiation questions that can come up are about rates of change. And rates of change is essentially just an application of the chain rule for these questions. So a rate of change generally means your variable is differentiated with respect to time. That's the rate of change in time, and typically a rate of change question is all about how a variable is changing in time. So in this case, that would perhaps be how a volume is changing in time, or maybe you'll have a surface area is changing in time, or a length is changing in time, or some variable, and we're looking at how it changes in time. Typically, questions will be guided as this. You have given one variable as a function of another. You're told perhaps that dx by dt is some number, and you're asked to find dy by dt when x is some other number. And it's just a case of using the chain rule in an applied setting. So let's have a look at 3 example questions of this. So we've got the figure to the left there shows a regular pentagon, and the area of the pentagon is given as this thing, 0.625 x squared times the square root of 10 plus 2 root 5. And we're asked to find the rate of change of the area when x is increasing at a rate of 1 millimeter per second and x is 5 centimeters, giving your answer to 3 significant figures. Okay, first thing to notice is that x is in centimeters, and we're told the rate of change of x is in millimeters per second. So the rate of change of x, which I can write as dx by dt, that is the rate of change of x when x is increasing at a rate of, that is going to be written as 0.1 centimeter per second. Okay. Just because you need your units to be consistent, I'm going to stick with centimeters, given that the diagram says centimeters there. So I'm going to convert the millimeters per second to centimeters per second. So that's the rate of change of x with respect to time, and we're asked to find the rate of change of the area. So we are asked to find dA by dt. So we can say that the dA by dt is the same as dA by dx times dx by dt. That's using the chain rule. And if you look, the dx's cancel, and we're left with dA by dt. So we need to find dA by dx. Well, we're given that the area is equal to 0.625x squared times the square root of 10 plus 2 root 5. So we're given a in terms of x in the question. So we can find dA by dx by differentiating this. So the only variable here is the x squared. So I'm going to times by 2, which is 1.25x, times the square root of 10 plus 2 root 5. So there is an expression for dA by dx. So I can plug that into here, along with what I'm told in the question, dx by dt, plug that into there, and that gives me dA by dt, and that will be in terms of x. So that's going to be 0.125x times the square root of 10 plus 2 root 5. Okay, dx by dt was 0.1, so that's why the 1.25 is now 0.125. We're asked to find the rate of change of the area when x is 5. So what we need to do is take the rate of change of the area and plug in x is 5. So dA by dt at the point when x is 5 is going to be equal to 0.625 times the square root of 10 plus 2 root 5. And we are asked to give that to 3 significant figures. So on the calculator, I'm going to type in 0.625 times the square root of 10 plus 2 root 5. That's the exact answer. And to 3 sig fig, that is 2.38. And the units, well, it's area over time. So that's centimeters squared per second. So that is how much the area will be increasing by. Okay, that's the first example. Second question. The surface area of a sphere is increasing at a constant rate of 8 centimeters squared per second. Find the rate the volume is increasing when r is 5. So this time we're not giving any formula, but you need to know that the surface area of a sphere is given as 4 pi r squared, and the volume of a sphere is given as 4/3 pi r cubed. So with these questions, I recommend you write down what it is you're asked to find. So in this case, the rate the volume is increasing, so that is dv by dt. And then let's have a look at what we've got here. We've got r, we've got a, and we've got t. So I can write that as perhaps dv. Well, I can find dv by dr. That's definitely we're able to find that. If I want to cancel the r, it's got to be dr by something. Well, I've got r and a over here, so I can find dr by dA, and then I need to cancel the a, so that's going to be by dA by hopefully dt, and we're told that the surface area is increasing at a constant rate of 8. So the surface area of a sphere, the surface area is increasing at a constant rate, and that's exactly what that is. That is the rate of change of the surface area. So we've got all three of those, or at least we can find them all. So dv by dr, that's going to be 4 pi r squared. dr by dA, well, I can find dA by dr. So let's do this over here. dA by dr is a differential of that, which is 8 pi r. And I can reciprocate that to find dr by dA is going to be 1 over 8 pi r. Okay. So dr by dA is 1 over 8 pi r times dA by dt, but we're told dA by dt is 8. Okay, so that gives me dv by dt, the rate of change of volume in terms of r. I can simplify that a little bit. The pi's will cancel, the 8's will cancel. I'm left with 4r. And I want to find the rate the volume is increasing when r is 5. So I'm just going to plug in r is 5 into here. So dv by dt when r is 5, well, that's going to be 4 times 5, which is 20. And the units for that would be a volume, which in this case is centimetres cubed, so everything's in centimetres per second, because that was in seconds. So that is centimetres cubed per second. There we go. And the final example question. We have water is flowing out the bottom of a cylindrical tank at a rate of 84 root h centimetres cubed per second, where h is the height of the water level above the base of the tank. The diameter of the tank is 1 metre. Find the rate of change of h when h is 2 metres. Give your answer to 3 decimal places. Okay, so we are told in the question that water is flowing out the bottom of a cylindrical tank at a rate of 84 root h centimetres cubed per second. And if you're unsure of what derivative that's going to be, and it's definitely a derivative because of the word rate, then look at the units. We've got a centimetres cubed, which is the volume, per unit time per second. So that's going to be a volume per second. So therefore that must be a differential of the volume with respect to time, which makes sense. It's going to be how much water flows over a given time period. So that's 84 root h is dv by dt. Now we also know that v is pi r squared h, because that is the volume equation for a cylinder. And we're told it's a cylindrical tank. Okay, that word is there for a reason, because we need to work out the volume in terms of h, because we're going to need dv by dh. Which is going to be 2 pi, no it's not, it's going to be pi r squared. Now r is the radius of the water, but we're told in the question that the tank has a diameter of 1 metre, so therefore the radius of the tank is 50 centimetres. Don't forget, because this is centimetres cubed, we should work in centimetres. Okay? So therefore this is actually 2,500 pi. Okay, it's 50 squared times pi. So dv by dh is 2,500 pi. Find the rate of change of h. So what the question is asking me to find is it's asking me to find h by dt, that's the rate of change of height, and that's going to equal the h by dv times dv by dt. Okay. And again, the dv's will cancel, we're left with dh by dt. Now dh by dv is the reciprocal of that, which is going to be 1 over 2,500 pi, and dv by dt, we were told in the question, is 84 root h. And we're asked to find dv by dt when h is 2 meters. So that means h as a value is 200. So dh by dt is going to be 84 root 200, all divided by 2,500 pi. Approximation for that. So 84 root 200 over 2,500 pi is 0.15125, and we want the answer to 3 decimal places, and it's going to be centimeters per second. Centimeters because it's height per time. So to 3 decimal places is 0.151 centimeters per second, and that answers that question. Okay. Thank you for watching. Try some out yourself, there's lots in the textbook, and again, message if you have any questions.